This is Levi back doing some more Microsoft Paint economics. Today we're going to be talking about equilibrium. So equilibrium is much more straightforward than most students think. It really is just like, can you spot the thing that's the same? Obviously, there's more complicated versions of this. The higher you go in econ, the harder it gets. And like, if you end up having one of the classes in 101 that does step functions instead of lines, things can get kind of weird. If at some point someone wants me to talk about that, let me know. But here what we're going to do is we've got our quantity supplied, quantity demanded, and price all in this table. 99 out of 100 times they give you this table. What you need to do is look at this table and find a place where quantity supplied and quantity demand equal each other and find the price. So what that means is that my QD, I don't want to use blue here. I'm just going to go back to black. Actually, I'll color code. So we know that P is equal to 5. We know that QS equals QD equals 5. When you talk about equilibrium, so with equilibrium, I can't spell that, equilibrium, there is only one price and quantity. Okay, you're never going to hear somebody say, and it's technically true, but they just don't say it. You're never going to hear somebody say the equilibrium price is 5, the equilibrium quantity supplied is 5, the equilibrium quantity demanded is 5. No, they don't do that. So what they're going to do is they're just going to say Q equals 5. And so your equilibrium would be P equals 5, Q equals 5, right? And some instructors care about units, some don't. So you'd be like, the price is $5, the quantity is 5 barrels. Quantity is 5,000 cars, the price is 5 rupees, like whatever. But this is 4.5 out of 5 at the absolute worst. Now, a couple things to point out. These numbers here in this line, they're all exactly the same just because I made it that way. Like, it was really easy to come up with these numbers and put it in there. It doesn't have to be that way. It's possible. Like this right here, if I did P equals 7.23, Q equals 109, totally fine. That would be the equilibrium if that's what the chart said. Like you just got to go by the chart. So I'll make up another quick example here where that's not how it works, or it's not just all 5s, and you'll see what I mean. So we've got this chart here. A couple other things to point out, besides the fact that hopefully you quickly eyeball this, and you're like, oh, 123 equals 123, which means my equilibrium price is 90. My equilibrium quantity is 123. That's totally fine, very valid, very easy. One thing that'll trip up some students is that first chart, everything was changing by 1s. Sometimes you'll get charts that change by 2s. You'll get charts that change by 10s, whatever. And this one I intentionally chose just random numbers. There's no pattern here. If you found a pattern, congrats, it was not intentional. I was literally just writing down numbers. Notice that 112 to 123 for quantity supplied, that's a difference of 11. 123 to 151, that's a difference of 28, right? Like not the same. And maybe the next difference is 7. I didn't go out that far because I didn't want to make a whole table, but that's the idea, is the quantities can just be totally random, totally change. Prices can do that also, but I have yet to see an Econ 101 that isn't just a price pattern, like 1, 2, 3, 4, 5, 10, 15, 20, that kind of thing. You could have something that was like 85, 92, 98, 110, like sure, but I've never seen it. Lastly, for equilibrium, we are going to talk about solving it if you have 2 equations, and I'm going to write those real fast and then come back. All right, so I again intentionally chose some numbers that are going to work out fairly nice and easy for us, but they don't have to be. You could get fractions, decimals, rational, irrational, all sorts of stuff. When you get to later, like if you're doing calc-based, hopefully you aren't needing these videos, but like if you get to calc-based or you get to grad level, you're going to have stuff where it's like e squared over pi, and it's just what it happens, okay? But here, what you want to do is for equilibrium, take the red equation and take the blue equation and set them equal to each other. So the red is going to be 2p. The blue is 50 minus 3p. And from here, you're just going to solve it like a totally normal 100% algebra problem. ignore every econ you've ever taken. Don't freak out. Don't get lost in the sauce. Like, just solve this for P. You're like, oh, okay, I can solve that for P. I'm going to go to black because we're going to be commingling. You're like, oh, okay, so I get 5P equals 50. P equals 10. Awesome. Your equilibrium price, usually denoted as a star. I'm pretty loosey-goose with that, but if you're on a multiple choice test, your equilibrium is probably just going to be P star given to you. But if you're on a free response or short answer test, to make it easier on your graders, pro tip, as a grader, make it as easy on them as possible. Box your answer. Don't write your answer on 3 different pages or in the margin of number 2 when you're answering number 10. Like, don't do that. So for equilibrium, you can star it. You can box it too, but like if you star it, that at least really helps. So we know our equilibrium price. We don't know our quantity yet. You can plug it into either of these equations. Does not matter. You should get the same answer. If you don't, then you don't have an equilibrium. So let's check our QS. QS is equal to 2 times 10. I'm plugging in the 10 for the P, by the way. And then let's check our QD. What do you know? I magically got the same. We knew we would because otherwise we would not have, again, I'm trying to color code as much as I can, we would not have our equilibrium quantity is equal to 20. So in this one, our equilibrium price is 10, our equilibrium quantity is 20. And that's basically it for equilibrium. You can have harder equations, obviously, you can have worse graphs, you can have worse tables, but that's the idea.